exploring space, something I wish we were better at. I have a little quote here. This is from Carl Sagan. It says this: "We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology. None of you know how your smartphone works, even though you all use your smartphone. None of you could take it apart and put it back together again. Yet at the same time, I would argue technology and science are going to become more important, not less important." So one of the things I'm trying to give you folks this year, Josh, is kind of a wide grounding, but I'm also trying to give you a curious mind so that you'll ask questions and read and learn. I wrote here, there's a very cool app from NASA. Please install it, called Spacecraft 3D. I encouraged you actually to install it earlier. If you haven't, it's available for iOS and Android. It's way cool. Make sure it's the one from NASA. If you run it and give it permission to access your camera, and then you focus, there's these little handouts that I print out. It gives you 3D models of our current probes from NASA, and you can move the camera around and get a good look. But I'm not going to spend time. I did that earlier this year already. Instead, let's jump on in. Right now, it's very difficult and expensive to send a person or anything into space. Costs approximately $30,000 per pound. And if you're sending a person, most of that $30,000 per pound isn't the person, it's the life support. That's way more mass, way more expensive. And so rather than send people, we use satellites, rovers, and probes to collect data for us. The company SpaceX right now that Elon Musk owns is trying to get this number much lower. You may have noticed a while ago he was able to, well, you know what? I got that in my lesson. So, space-based technology. There's three main types. We have artificial satellites. Satellites orbit a planet. They don't land. Their job is take pictures, remote sensing, and communicate back to us. Okay? Then there are probes. Probes may pass by numerous planets, and sometimes they'll land, but once they land, they can't move. The New Horizons Pluto was a probe. It's not orbiting Pluto. In fact, we sent it so fast that it went zipping by Pluto very quickly. We couldn't pack the fuel to slow it down because that would have made it even more expensive. We gave it enough fuel to get it there really fast and then said, take pictures as you go zipping by. Their job is to send data back to Earth. And then we have rovers. They are sent to a specific planet and they can move around. They can rove. That's what we call them, rovers. They send data back to the Earth. What planets do we have rovers on right now that you know of? Okay, definitely Mars. So we have the Mars rovers. The two main ones are Spirit and Opportunity. Those ones landed in 2004. They wanted to study the history of Mars, especially the presence of water. Why water? Why are we so interested in water? Anywhere we found water on Earth, even in places where we thought life could not exist, we have found microbial life. Not intelligent life, but at least bacteria, microbes, that's a start. So if we can find liquid water, and if we find life there, then that will change everything. If we find liquid water and we find life on another planet, then we'll say, oh, life isn't a fluke, it's almost inevitable if you have liquid water, because if two planets with liquid water both evolve life, then maybe life is everywhere in the universe. That would change our understanding. The rovers have lasted way longer than expected. They were supposed to last around 90 days. From 2004. Spirit lasted until March of 2010. Opportunity is still going strong. Why have they lasted longer? So they get their power from solar panels, but the solar panels get dusty And as they get dustier and dustier and dustier, you have less and less power. And so NASA figured we'd get about 90 days of power. What we did not count on was in the winter, the storms come by and they blow the dust off the panels and clean them. And we have more power. It was a pleasant surprise. Have to give you a little nerd comic. Oh, sorry. First of all, we have, this is the path of the, I can't remember if this is opportunity or if this is spirit, but it's gone quite a distance. The rovers have to be semi-autonomous. They have to be able to think okay for themselves and drive on their own, because it takes light and radio signals anywhere from 7 minutes to 13 minutes to get to Mars. So trying to drive it like you would a video game wouldn't work, because you would see a cliff and you would say stop. Actually, no, it fell over that cliff 12 minutes ago because it took that long for the image to reach you and go back. So the rover, it's some pretty impressive engineering they have to build into them. Here's the rover. Day 1 of 90. 89 days to go. Day 88 of 90. 2 days until I go home. Day 91 of 90. Huh? Day 103 of 90. Maybe I didn't do a good enough job. Day 127 of 90. Maybe if I do a good enough job, they'll let me come home. Day 857 of 90. I thought I analyzed that rock really well. It's okay. I'll do the next one even better. Maybe they'll let me come home. Day 1328 of 90. Sandstorm. Power dying. But a good rover would keep going. A good rover, like they wanted. Day 1944 of 90. Oh no, I'm stuck. Did I do a good job? Do I get to come home? Guys? If rovers could think, maybe that's what they would have thought. Maybe. New mission from 2012. What's the name of the huge rover we have on right now? You guys don't know? The Curiosity rover. This was one of the most impressive feats of engineering NASA has ever done. Getting it there, it's the size of a minivan. It's huge. Landing it, previously we've landed with parachutes or we've landed with airbags, but you could do that with small rovers. We wanted to send something big with lots of instruments, fragile instruments. We have to somehow land this thing gently. How, you ask? How, you ask? How, you ask? How? I'm so glad you asked. Put your pencils down. How many of you have a Twitter account? A few of you? Curiosity tweets at Mars Curiosity. Followed. It's good stuff. So where did it land? Here's some, here's a Curiosity selfie that was stitched together from multiple images. Some Mars geography. So we've landed here. Here is the Gale crater. This is where Curiosity is. And we've also sent a couple of probes in here. I'm not going to ask you to memorize that. This is purely for nerd trivia. Let's talk a bit more about Mars. Mars has polar ice caps that shrink and expand every year. Does Mars have seasons? We answered this last class, if you really recall. Why? One word. It also has an axial tilt. How long is a day on Mars? How many hours? Anybody know? It's a little longer than Earth. Not much. I think it's 26 or 27 hours. But all of the NASA staff that are running the Curiosity rover, they run on Mars time. They have special watches for Mars time, and they just, so it kind of wreaks havoc because sometimes you'll be working during the nighttime here on the Earth, and then sometimes eventually be working during the daytime here on the Earth, but they're very committed. They're running on Mars time because that's when stuff happens there. Mars has some interesting features. Mars has the highest mountain in the solar system. It's called Olympus Mons, Latin for Mount Olympus. It's almost 3 times taller than Mount Everest. It has the deepest chasm or deepest canyon called Melas Chasma. Way deeper and longer than the Grand Canyon. This is part of the evidence that there once must have been lots of water on Mars, and that it's evaporated over the millennia. There's a picture I found online of the Melas Chasma. I wish I had some kind of scale. It's deep. And Mars has lots of water ice. Why is this important? Hannah, on Earth, wherever we find water, we find... You answered that already. Now, please understand, by life, Tensei, I'm even just talking tiny one-celled microbial life, but that's life. I'm not saying animals. I'm not saying intelligent life. I'm not saying Martians. But there is life. What is some evidence for past water on the surface of Mars? This is already slightly out of date because just from the time your textbooks were published, we have found more evidence. But for now, there's polar ice caps. There's small amounts of water in the atmosphere. Moisture in the air. It's just the atmosphere is really thin. There's certainly pictures of what appear to be ancient lake and riverbeds and evidence of erosion by water. There's also evidence of ancient glaciers. We have discovered that there are minerals present that only form in the presence of water. So there was all this evidence. This was around when your textbook was published. Your textbook was published about 7 or 8 years ago. Since then, more updates. The Phoenix lander in 2008 exposed, not water, ice as it landed. It watched those chunks of ice sublimate, evaporate, because it's very cold and dry. It detected snow falling as it impacted because it kicked up some ice crystals. And it even briefly saw drops of liquid water. Water today. This was as of 1 year ago in my notes, and it's crossed out. So I said, today the atmosphere is too thin and cold for liquid water to exist. It would freeze and sublime, turn straight to a gas very quickly, so all surface water has long since disappeared. No! It's always nice when we make new discoveries. Newsflash, on September 28th, 2015, NASA confirms that liquid water is still occasionally flows on Mars. There are cliffs that have been nicknamed the Weeping Cliffs because we can see water and not like a waterfall, but there is liquid water there. I think that's NASA's next destination to send a probe. In each cubic meter of Martian soil, Curiosity has found that there's about 30 liters or so of water, which means if we do have a Mars mission, if we wanted to... How many of you saw the movie The Martian? So in that movie, Christian, and the author has commented, literally, I think a week before the movie came out, NASA found all this water on Mars. In the movie, Matt Damon's character burns hydrazine to create water. Totally unnecessary now. Matt Damon would have just lugged in some dirt and let the water evaporate into the Hab. Thrown that dirt out, lugged in some more dirt, let the water evaporate into the Hab. Much safer, easier to do. So that movie, while it tried to be accurate, science changes, our knowledge changes that fast. It's generally now believed that Mars had abundant, lots of water very early in its history, during which snow and rain fell and created lakes and rivers and probably oceans. Life may once have existed on Mars. Microbial life. Intelligent life? We don't think so. Although, it's possible that this is what's going on the whole time. So here's the rover. He's saying, hold still, Larry. It's taking another picture. Maybe they're just holding stuff in front of the camera the whole time and we never see anything. I don't think that's very likely. Why do we care that life may have existed? I wrote here, pause taking notes, for but keep listening. So, Mars research up until the Curiosity rover, we've always been fascinated by our closest neighbor. Studies started in the 1600s with telescopes, and the first map was published in 1840, the first map of Mars. There have been many missions to Mars by many countries, but until recently, there was a high failure rate. The first successful flyby was in 1964. The first successful orbiter, satellite, was in 1971. We currently, you know what, I have to check. Last I checked, a year ago, there was 3 in orbit. We might have more now. The first successful lander was in 1982. Right now, we have 3 landers on Mars. 3 landers. Landers land but don't have wheels. So there was 3 of those. Viking was one. Oh, come back. The first successful rover was in 1997. We've sent 4. 2 are still going. Curiosity is still going. By the way, Curiosity was only supposed to last for 2 years. It's on year 4, so it's done well. Brooke, you with me? You're not foolish looking at your phone or anything like that? No. Silly. Rovers can move around. He followed me home. He says his name is Rover. Oh, okay. So currently there are 2 rovers on Mars. Opportunity landed in 2003, meant to be a 90-day mission, still going strong. Curiosity landed in 2012. There are 5 active satellites currently orbiting Mars. I even found a picture. This is what it looks like. These are all the satellites going around Mars. So there's the Curiosity rover. This is a little timeline. You can't read all this, but I pasted it in here out of enthusiasm because I'm kind of nuts. You know what? Here's a lovely picture of the Curiosity rover. Curiosity rover has many different instruments. It's got a laser. It's got a way it can drill into rock. It can take rock samples. It can scan them for life. It even has a sundial, a Mars dial. Bill Nye insisted they put one on there. Antenna that can act like a little sundial and take pictures of that. Pictures from the Curiosity rover. How hard was it to land Curiosity on Mars? The video that you saw, narrated by William Shatner, did not do it justice. Watch. Close that, Mr. Duick. How do I close that? Dropbox. Close. Oh, good gosh, Mr. Duick. Hang on one second. This is what happens when I hit the wrong thing. A lot had to go right. Stages had to separate, parachutes had to open, rockets had to fire, a lot had to go right. So, Curiosity specifications, just under 11 feet or 3.3 meters long. Its length is about a little higher than a basketball rim. It's big. 9 feet wide, a little shorter than a basketball rim height. 7.5 feet tall. weighs about 900 kilograms, about as much as a car. Top speed is 140 meters per hour. Can't go very fast. We don't want it to go fast because it could go off something and break off a cliff. It landed on August 6, 2012. It's expected to last 2 years, 20 miles. Still going. In fact, I think it just recently hit 26 miles and counting. It costs money. We landed by the Gull crater. Why there? Strong evidence for the existence of water, so a better chance of finding evidence of any forms of life. It's a big crater. It's 150 kilometers across with a large mountain in the middle. This past summer, a probe called New Horizons did a flyby of Pluto. It was launched in 2006. It was the fastest man-made object ever launched, but it still took over 9 years to get to Pluto. The data is fantastic. When it arrived at Pluto, it was moving so fast that it could only do a flyby. It's now heading into the Kuiper Belt and beyond. Start taking notes again. Let's talk about space travel. Right now, we primarily do all of our space travel with rockets. They're used to transport materials and astronauts into space. Most of the body is filled with explosive fuel that burns to create the thrust, the force that causes the movement. Then for a while, we had the space shuttle. Most of it was reusable. Only the fuel tanks were discarded. It launched and retrieved satellites. It had a very big carrying capacity. The Hubble Space Station, the Hubble Space Telescope, the International Space Station, those went all up with the shuttle. And it also delivered supplies and astronauts to the International Space Station. But now they're all retired and in museums. Anybody seen one live? No? I have. So in Los Angeles at their Science World, in LA, they have one of the space shuttles. Also, Mr. Dewick sucks at taking selfies. Okay? Then I said he needs to show you a cool picture of the sun. I showed you that a while ago. That was the ISS and the space station and the space shuttle all silhouetted against the sun. So we'll pause, keep going. How do we go to space? Like this. Pencils down. ISS, or the International Space Station. This is the space-based laboratory that orbits about 350 kilometers above the Earth. Orbits every 96 minutes or so, roughly every 90 minutes. Astronauts live there for extended periods of time. Who was the Canadian astronaut that once lived there and commanded it? Commander Chris Hadfield. The ISS is a pretty impressive, a pretty incredible collaboration between nations. Put your pencils down again. We have a recent ISS commander. His name was Scott Kelly. He was an American, is an American. And Scott Kelly lived on the ISS for a year and just came back about 2 months ago. He has a twin brother who is a retired astronaut. Why is this so helpful for research? Okay. So, his brother on Earth followed the same diet and exercise routine as Scott. What do you know about twins? They are genetically identical. Because they're genetically identical, this allowed NASA to compare two identical genes, genetic patterns. It's a great idea, because we're trying to still study the effects of weightlessness and the exposure to open space on humans. The effects, Cole, are not good. But this was a neat opportunity. Kind of cool. Okay. So his twin brother followed the same routine, ate the same diet, did the same exercise patterns, and they both went through the same medical tests at the same time. Gave NASA some really good data. Great pictures from outer space if you subscribe to some of the astronauts' Twitter accounts. Video NASA Johnson style. I played that one for you the other day as you came in. So a little bit more, we're going to be done for today. Some NASA spin-off technologies. I wrote down here, you're going to write down the spin-off technologies from the video in your notes. So here we go. So what else do we have to deal with? Well, here's one. Space debris. There's lots of junk up there, and it's all moving around the Earth core very, very fast, and that can be dangerous to other objects that are moving around the Earth very, very fast. Put your pencils down, look up. SpaceX, owned by Elon Musk, billionaire, and Blue Origin, owned by Jeff Bezos, who also owns Amazon, are two private companies attempting to lower the cost of space travel by developing reusable rockets that land back on the Earth rather than burning up in the atmosphere. And just recently, only about a month and a half ago, SpaceX pulled it off. Space travel is also very dangerous. How many space shuttles were built? Does anybody know? Yep. Yep. How many exploded with astronauts aboard? What percentage or what fraction is that as a failure rate? 1 out of 3. Space travel is dangerous. How dangerous? Put your pencils down.